Transition to a fully zero-emission transport ecosystem is a complex process involving many stakeholders and fleet operators. In the case of urban freight and logistics, understanding the needs, challenges, and interests of the various communities is key to enabling collaboration and devising effective routes and incentives for e-mobility deployment. The EU-funded project Elbiten conducted a survey in 2018 with fleet managers with respect to the usage of light electric vehicles for urban logistics deliveries. They identified many advantages of light electric vehicles. They are environmentally friendly and have lower carbon footprint and present lower cost for maintenance and use. You can use them to access limited traffic zones, clean air zones, and they give flexibility in traffic. They make lower noise and they are safer than traditional cars and vans as they run at lower speed. However, some disadvantages should be overcome in order to make them a viable solution. In general, no unlimited recharging points are currently available. Electricity supply for depot charging is a complex issue, as well as the excessive duration of charging times and battery autonomy. Batteries can also be stolen. And finally, there's a limited choice of models. In terms of measures to support and promote light electric vehicles, the availability of electric charging infrastructure and dedicated delivery space on streets are identified as the most important ones. We have seen that electric charging infrastructure plays an essential role in electrification. The case study of Amsterdam and the needs for fast charging infrastructure for urban logistics vehicles is an interesting one. The study, carried out by different Dutch researchers for Connect and top sector logistics, is applied to the context of the city of Amsterdam, whose ambition is to have urban logistics electrified by 2025. This means 3,000 commercial vans and 5,000 freight trucks. Here, issues to be solved are different. How to electrify the current operations, where and how to charge, and what's the impact on the grid. Charging infrastructure for zero-emission vehicles is a major hurdle for many freight operators. A coherent and dedicated strategy needs to be developed in concert with both logistics and charging infrastructure operators, but also with energy providers. This should take into account the specific needs of each freight subsector, as well as the balance between public and private infrastructure. The analysis addresses three charging scenarios: without intermediate charging, with intermediate charging, for example with a pause for the driver, and charging during deliveries, for example many small charges, the so-called opportunity charging. The study also looks at the current charging habits, differentiating between vans and trucks. Commercial vans largely charge at home or at depot. For this category, fast charging is limited due to cost and time, as well as charging at customer. For this type of vehicles, home charging should be made possible. On the other hand, trucks largely charge at depot. Fast charging is limited at the moment, and client charging is higher than for vans. But of course, no home charging in this case, given that trucks stay at the depot. When it comes to understand the ecosystem, it is important to segment the charging needs per sector. Retail food and non-food mostly charge at the depot. For long trips, more than 100 kilometers, charging at customer premises is more likely. Building and construction sector, for them vans mostly charge at home, trucks at depot. Charging at building sites requires innovation and temporary solutions. For the postal services, charge mostly at home and at the depot is likely. Fast charging is not required due to limited range. For service logistics, eventually, home charging is most frequent. This analysis basically says that depots for trucks and homes for vans require major charging infrastructure investments, while most public chargers are required outside the city center and outside Amsterdam's environmental zone in the specific case. This would typically be used by commercial vans in the service build logistics, and buildings and construction sectors. Cities should develop e-fleet supporting schemes while simultaneously considering the different charging needs of operators when advancing the electrification of fleets. The European-funded project Assured aims at boosting the electrification of urban commercial vehicles and their integration with high-power fast charging infrastructure. Assured tests electric buses, waste collection and delivery trucks, as well as one light commercial delivery vehicle with innovative fast charging solutions. The goal is to showcase the interoperability between different brands of vehicles and charging solutions, providing more flexibility to the public transport and freight providers in their daily operations. Focusing on the freight dimension and similarly to the Dutch study, the research carried out in the project shows that the current charging infrastructure system does not support the operations of logistics operators, which do not have fast charging points at the strategic parts of the cities. At the moment, operators who want to go electric must bear the costs related to the installation of a charging infrastructure in their own depot, for the benefit of the subcontractors who work on their behalf and who in turn have to bear the costs of buying an expensive electric vehicle, despite they don't have a stable contract with the logistic operator. The urban freight operators, owning their own fleets, charge their electric vehicles in their own depots overnight and at a low current. This process is generally slow and requires one charge point per vehicle. Furthermore, this charging method is best adapted to urban freight operations for which daily distances are limited. Although it has been demonstrated that about 80% of the daily distribution operations in the city fall within the charge range of a normal electric van, for some the battery range currently available can be an issue and might limit the wider uptake of the full electric vehicles. Given these challenges, the project provides for some considerations. Upscaling is needed to overcome challenges linked with the energy grid and lack of space. The deployment of charging infrastructure should go hand in hand with smart energy use and renewable energy strategies. Cities should closely work with service providers to make sure that data on the charging needs and usage are available and accessible. On-street infrastructure design of fast chargers should consider the specific needs of freight in terms of position and power. Fast opportunity charging should be coupled with a pre-booking system and some more added value services for drivers.